Okay, good morning everyone. Today we'll look at applying properties of logarithms to base e, the natural base. Our last lesson we solved word problems involving base e. Today we'll look at applying properties to base e. So the first property we'll take a look at is the product property of logarithms. We've seen this before, which basically says that when you add two logs with the same base, you multiply what you're taking the log of. So here I have the natural log of 4 plus the natural log of x. I multiply the 4 and the x, so 4 times x gives me 4x. I have the natural log of 4x is equal to 2. Then I apply the inverse property, so e raised to the natural log of 4x equals e squared. And that leaves me with 4x is equal to e squared. And then I divide both sides by 4. And then I get x is equal to e squared divided by 4. Again, another example. I have the natural log of 3 plus twice the natural log of x. I have to first apply the product or the power property. I need to move that squared back up, or 2 back up. So that gives me the natural log of 3 plus the natural log of x squared. And then 3 times x squared. And that will give me 3x squared. So I have the natural log of 3x squared equals 7. And then I apply the inverse properties. So e to the natural log of 3x squared equals e raised to the 7th. That gives me 3x squared is equal to e to the 7th. Divide both sides by 3. I get x squared is equal to e to the 7th divided by 3. And now I have to take the square root of both sides. So I get a plus or minus, so I get positive, the square root of e7 divided by 3, and then I get a negative, the square root of e7 divided by 3. But I can't use the negative because the domain of a log function has to be greater than 0. X can't be negative. Let's look at the quotient property, which says again that if you're subtracting two logs with the same base, you just divide what you're taking the log of. So here again, I have to first apply the undo the power property. So 2 natural log of x gives me natural log of x squared. So I have natural log of x squared minus 4. Add 4 to both sides. I get the natural log of x squared is equal to 4, and an e raised to that, and e raised to that. That gives me x squared is equal to e to the 4th. Then I take the square root of both sides. I get x is equal to plus or minus e to the 4th, which is just e squared and negative e squared. Okay, but again, I can't use the negative because the domain of a log function has to be greater than 0 in that case. And then again, the inverse property. So e to the natural log of x cubed equals 27. Well, that's just x cubed. It's equal to 27. And then that would be x is equal to 3. That would be x is equal to 3. So the inverse property. Now we'll take a look at finding inverse of transform, exponential, and log functions. In order to find the inverse, well, before we would find the inverse of like 5 raised to the x, that's just log base 5 of x. The inverse of log base 7 of x, that was just 7 raised to the x. And then the inverse, of course, of e raised to the x, that's just the natural log of x. But what happens if we have y is equal to e raised to the x plus 4? What is that inverse there of that function? Well, we'll find the inverse of that function. But in order to do so, this is what we do. We switch the x and y and solve for y by applying inverse properties. Now, it may be helpful first to take a look at the graph of this function. So it's an exponential function. Okay, notice here I have a plus 4, so basically that's going to move my asymptote, my horizontal asymptote up 4. So 1, 2, 3, 4. Okay, so I'll have that imaginary line, and my exponential function will look something like that. A space. Okay? But my asymptote will be at y is equal to 4. That would be my asymptote. Now, the domain, again, this is an exponential function, will be all real numbers, but the range will be y is greater than 4. Okay. That's what the function y is equal to e raised to the x plus 4 looks like. I move the asymptote up 4. Now, how do we find the inverse function? Well, if you remember what we learned about inverse functions, the range then of that inverse function, the domain of that inverse function, well, that would have been the range of the original function. So my domain now should be x is greater than 4. The range would be all real numbers. And then I should have a vertical asymptote at x is equal to 4. Again, we just switch the x and y's. We switch the domain and range. Okay, so in order to solve or find the inverse function for this, what we do is we just switch the x and y and solve for y by applying inverse properties. So this is going to be x is equal to e raised to y plus 4. First, I have to subtract 4, so x minus 4 equals e to the y. Now, if I take the natural log of both sides, okay, so here, I take the natural log of both sides, I'll have the natural log of x minus 4 equals the natural log of e raised to y. Well, that just gives me the natural log of x minus 4 equals y. So there's my inverse. And as you can see, the inverse of that, or my domain, now it has to be x is greater than 4. You see, if I had x is 3, 3 minus 4 would give me negative 1, and I can't have a negative in the domain. So I moved my vertical asymptote 4 units to the right. Okay, and then that will look something like this here. So the inverse to y equals e raised to the x plus 4 is the natural log of x minus 4. That's the inverse. Switch the x and y's and solve for y by applying inverse properties. So again, the next example here, so I have y is equal to the natural log of x plus 2. Now, again, if I were to briefly graph that, again, keep in mind that the inverse, the domain of a log function, it has to be greater than 0, which means I can't have x be less than negative 2. Otherwise, I'd get a negative number. So this graph will look something like this here. I'll have a vertical asymptote. At x is equal to negative 2. I can't have anything less than negative 2, otherwise I get a negative in the domain. The domain of a log function has to be greater than 0. So when I look at this, then my domain should be x is greater than negative 2. The range will be all real numbers, and then my asymptote will be at x is equal to negative 2. So for the inverse function then, the domain should be all real numbers, but the range should be y is greater than negative 2, and then my horizontal asymptote will be y equals negative 2. So that's what I should have. We just switched the domain and range, the x and y. Okay, so let's look at this. So again, how do we find the inverse function? Again, we just switch the x and y's and then we solve for y. So this is going to be x is equal to the natural log of y plus 2. Switch the x and y. Now I have to apply the inverse property. So this is going to be e raised to the x and e raised to that. Now this is going to give me e raised to the x equals y plus 2. And then finally I get e raised to the x minus 2 equals y. And there's my inverse. Okay, as you can see, my horizontal asymptote would be at -2. So at -2. And it would look like an exponential function. So it will look something like, let's see here. Yeah. Okay. So there, I'd have a horizontal asymptote at y is equal to -2. And that would be the inverse function here. Okay, so very easy to find the inverse function. You switch the x and y, and then you solve for y.